Well, it's been a while since I've made a video of our flying exploits with Mike Whiskey Delta, and you might be wondering why that was the case. Well, as is often the case in life, sometimes life gets in the way of doing things that we might otherwise prefer to do. But part of the reason also is that we have that Mike Whiskey Delta has had a major upgrade of a couple of its systems, and I wanted to share that with you here on this video. If you are not interested in a technical type of video, then probably this one's not for you. If you're just looking for a flying one, which we would normally do, then you might want to skip this one. But for those that are interested in some of the technical aspects of the ignition and electrical systems, then stay tuned and hopefully we can share something that might be helpful and interesting to you. So the aircraft was due to have its annual service. The major service has to be done on aircraft every 100 hours of flying or 12 months, whichever comes first. And so the Express was due for that. But at the same time, I realised that the battery, which was now 4 years old, the main aircraft ship's battery, was just about needing to be replaced. They're a little bit similar to car batteries, they don't last forever. I could tell that during cranking of the engine, it was just a little bit more sluggish, and I pretty much figured that it was going to be due for a battery replacement this time around, and in fact that was the case. And we took the opportunity to upgrade the battery to a new style of battery, which I think is far superior and has so far proven to be extremely good and has met or exceeded our expectations. A little bit more on that in a moment. But the second aspect that we were looking to do an upgrade on was the ignition system of the aircraft. Now, aircraft engines are in many ways extremely old-fashioned. The technology that is in these, and I've got a Continental, a 6-cylinder Continental, an IO550N. So it's a big 6-cylinder engine, 550 cubic inches, or that's around about 9.2 litres, horizontally opposed flat 6 air-cooled engine, and commonly used in many aircraft, Bonanzas, Cirrus SR22s, same engine, and a great engine. But the ignition system on these things is really ancient. It's the technology is 50 or 60 years old. Now, the aircraft engines historically have always been powered by magnetos. Now, magnetos are a very old-fashioned piece of technology, and you might wonder, well, why would that still be the case? Well, the reason is that magnetos, although they have a number of drawbacks and a number of disadvantages, one big advantage is that they are super reliable when it comes to just chugging away and keeping the engine spinning when all of your electrical systems fail, because it generates its own internal source of electricity. And there are many other YouTube videos that explain how that is the case. So a magneto is not reliant on ship's power. You can lose your battery, you can lose all your electricals, you can lose your alternator, everything can go dead in the aircraft as far as the electrical supply is concerned, but the engine will just still keep chugging away very happily on its own. And that's the one big thing, the one big advantage of magnetos. They have drawbacks. One of those drawbacks is that the spark that's produced is relatively weak, and also there's no ability to alter the timing of that spark being delivered to the cylinders. It's a fixed timing apparatus. In the case of this engine, 22 degrees before top dead center is the time when that spark should be delivered. That has to be changed though. There's a thing in a magneto called an impulse coupling that retards that spark for the purposes of starting, because you wouldn't be able to start the engine if the spark was firing so early in the cycle. And the impulse coupling is that little click that you would hear on a normal aircraft engine. If we were to turn the propeller, I'm not going to do that now because we have no magnetos in this now, but if you turn the propeller through a compression on a normal aircraft engine that has magnetos as its ignition system, as you pull it through that compression, you'll hear a distinct click every time, and that's the impulse coupling actually activating to produce that retarded spark. It's a relatively weak spark, but it's a spark, and it's enough to get the engine started, obviously. It's a little problematic for hot starting because it's a weak spark, and for hot starts, these aircraft engines don't like hot starting, particularly the fuel-injected ones, which this is, because you get vaporization in the fuel lines after you've shut down, if the aircraft's been stationary and shut down, and for about sort of anything from just a few minutes right through to an hour or so afterwards. Sometimes they can be really difficult to start because of that. So magnetos have disadvantages. Why can't we install something more modern? Well, that's what we have just done now. And I got interested in the electronic ignitions as a possibility, and like with most things, there are many choices. But for aircraft engines and electronic ignition, there's three big choices out there. Two of them for certified. One is one called Electro Air, another one is called Surefly, and the third one is called a PMAG or an EMAG, which is what we have chosen to install on this. The EMAG is not able to be installed on a certified aircraft. It's for experimental registered aircraft only at this stage. But the reason that I went for that as opposed to those other systems that are available is because the EMAG still has that one big advantage of the magnetos, and that is, sorry, we've got a rescue helicopter just coming in here and making a fair bit of noise. In fact, it's a firefighting helicopter that's just come in with a snorkel, down below. But the one big advantage that the PMAG has, or the EMAG system, is that it also, like a magneto, generates its own internal electrical spark. So it has more. It's not so much a magneto, but it has its own generator style of arrangement internally. So as the apparatus spins, it creates its own electrical energy, which can be used if the ship's power fails. So primarily it runs off the battery of the aircraft, but if that were to fail, it just seamlessly transfers over to its own internal source of energy, and that to me was a really big factor for me to choose this, because if you go for a fully electrical system that's entirely reliant on battery and electrical current coming from the ship, if you lose that, your engine will stop, and that's not a great thing in an aircraft. You can, and you have to really, to be safe, set up a redundancy with an extra battery and an extra electrical system to seamlessly take over if your primary source of electricity for the ignition system fails on those other systems. But that's not necessary for the EMAG, and that's what drove me to choose this. So that's one big upgrade that we've done, and the other upgrade is the battery. Now, the battery is also, as we have in car batteries, pretty ancient technology with the lead acid batteries. However, there are new lithium ion batteries that have become available now for aircraft, and that's what I've chosen to install. So we'll go through that in a moment. The reason for that is that the battery was needing to be replaced when it went in for the 100 hourly, and the testing was done. It fell below the capacity that is required for an instrument certified aircraft, an IFR aircraft, and which was no surprise to me. I figured that it was going to fail at this time. So it was time to upgrade, or it was time to replace the battery. We took this opportunity to do a battery upgrade. So what I'm going to do is we're going to pop the cowl on the engine, and I want to show you around a little bit as to what we have done, and also show you what's happened on the panel, because there are a number of extra circuits and switches and circuit breakers that had to be installed as part of this. So first of all, let's have a look under the cowl. Okay, so we've got the cowl off. Now, before we get into the magneto replacement with the EMAG system, I'll just show you the battery setup first, because that's also an important part of the upgrade that we've done. So I'll come around to put this side here, and this is where my battery setup is. Now, in this particular engine bay, this particular aircraft, we only had space for a relatively small capacity battery, just purely because of where our engine mount comes down through here. And this is a big engine, and it needs good cranking power for starting the engine, and we were only just marginal with the lead acid battery that we had. We would have preferred to have a bigger battery to crank this rather large engine, but we simply couldn't fit a bigger battery in, and so the one that we have had for the last literally 20 years, well, obviously being replaced every few years, has been only just adequate. Now what we've got here is, I don't know how well you can see that, but you can see here's the outline of the battery box that we had there, and but now we've got our new EarthX battery installed, and you can see that it's much smaller than the battery box that we had for the old lead acid battery. I'll show you the lead acid battery that it replaces. So here I've got one of the old lead acid batteries that we've been using for the last 20 years. Pretty standard fare as far as aircraft batteries are concerned, but it's old technology, lead acid, you know, pretty good performer, but I don't know if you can see, but it's significantly bigger than that EarthX battery that we've just put in, and this thing is a lump, and the new EarthX battery is smaller, lighter, and has got much higher cranking ability, so it's a significant improvement. So coming back around to our EarthX battery, the interesting thing is, if you can see the specs on it there, this is the ETX 900, and it only weighs 2.2 kilos in comparison to the old lead acid battery, but it's got, apart from all the other specs, peak cranking amps of 840, which is significantly better than the old Concorde battery. So it's been fantastic, but it's also got smarts built into it. It's got internal diagnostics and internal fail-safe abilities, so it's actually a smart battery. It's not just a dumb lead acid battery. One of the other advantages of the EarthX battery, the lithium iron phosphate battery, is that it has a life expectancy of about 6 years as opposed to only 3 or 4 years. Some out of the old lead acid batteries. Some owners of the lead acid batteries only get 1.5 2 years out of them. This has got an expectancy of 6 years, and hopefully it might even last longer than that. But also it can be left for 6 months without and will not require recharging even without any activity at all. So you get a 6 month charge out of it. So 2.2 kgs, and the Concord battery that it's replacing weighed 10.3 kilograms, so that's a significant weight saving, and a slight amendment to the weight and balance of the aircraft was required as a result of that, but that's a significant saving. Replacement of the ignition system, we've got these two big black units here at the back of the engine, these new PMags that have been installed, and these bolt onto the accessory case in the engine, and all of the red leads that you can see there are the new leads going out to the spark plugs in the engine both sides. So you've got a 6-cylinder engine with 2 spark plugs per cylinder, so a total of 12, and this system I've been absolutely delighted with so far. It has performed extremely well. The engine starts more easily. It's smooth and fuel and I believe to be more fuel efficient. I've only done 3 flights with it so far, but from what I can ascertain, I'm getting either better performance at the same power settings, i.e. a higher speed at the same power settings that I would have had previously, or I can achieve fuel savings, significant fuel savings, to go the same speed as I was previously. So I'm looking forward to checking that out a bit more as I'm able to start doing some proper tests on it at altitude and in a cross-country situation. Now, one thing that is of interest here is that part of this system uses automotive spark plugs rather than aircraft spark plugs. And you might think, oh, that's a bit of a worry. Well, not really, because the automotive spark plugs can actually produce a much higher spark energy than can the aircraft spark plugs, and the gap size on the spark plug is much greater, producing you've got a fatter spark, a bigger spark, and a more powerful spark that's coming out of the EMAG system. So pretty happy with it so far. So it can be set to run just in a fixed timing mode of firing at 22 degrees before top dead center, or it can be run at its variable setting, where it takes advantage of the changes in power settings, RPM and altitude to alter the timing of the spark, so that you get greater efficiency out of the engine. One of the just have to wait for a moment. Another fire helicopter coming back in here as well. So they've obviously been doing a bit of firefighting activity this afternoon. One thing you might notice is that the leads are all set up to be separated from one another. This is something that the EMAG people specified that was quite important, rather than bundling them all together, and so they've been set up so that they all run individually and don't touch each other, and it has run absolutely flawlessly so far. So the EMAGs here, the 2 of them together, running 2 different banks. They call them number 1 and number 2, as opposed to left and right, but essentially the same. And these units are also smaller and lighter than the Magnetos that they replace, which I've got here these are the magnetos that have come out of the aircraft. They are perfectly good and serviceable magnetos, so if anyone is looking for a here we go, genuine Bendix magneto, or genuine Continental Motors branded, because these are the magnetos that came with the engine out of the factory. These have only got about 50 or 60 hours on them since their overhaul that they require every 500 hours. So anyone that would like them, and I've got all of the accessory leads and so on with those, please contact me, because this might be just what you're after for your own 6-cylinder Continental engine. Alright, well, let's have a look and see what's changed on the panel inside here, and we'll open up and jump in here. Okay, well, those that have watched previous videos will be somewhat familiar with our panel. I don't have the iPads installed. iPad mini that goes in here, and the larger iPad that sits over here. But the major difference is in this little quarter panel here on my side, and we've got some new components that have been installed here. So first of all, let's start at the top here. I don't have anything powered up at the moment, but here we have a battery monitor light. That's new, so the smarts in the battery tell me here whether there is any fault that's occurring with the battery, or a discharge, or any internal fault or overheating or anything like that. And as part of the startup or pre-flight procedure, we've got a press to hold button here, which we can check, and that light will illuminate. It's not doing that at the moment because I don't have the master switch on. And then if we come down here, now we're looking at the new switches that are installed for the eMags. Now, what we've got, first of all, on the left here, we've got a little switch here which is testing the mags, the new eMags number 1 and number 2, and what that does when after engine start and so on, and during the run-up procedure, by flicking that up to number 1, that is taking away ship's power from the magneto, from the number 1 magneto in the front, which equates to the left. That's taking away ship's power, and so by doing that, that is testing to make sure that the internal magneto, or the internal generator, is providing the electrical energy, and similarly number 2 as well. A similar thing can be achieved by pulling these, and these are new circuit breakers that have been installed. We didn't have room over on our main circuit breaker panel because it was already full, so we've installed these here. But by pulling those circuit breakers, that's also depriving the mag of all of its ship's electrical power. And in fact, because of the way this is set up, if I have the master switch on down here, as soon as the master switch is turned on, those magnetos are powered. Now that means that if the master switch was on and someone grabbed the propeller at the front and turned it, there's a chance that the engine could fire, and that's a very dangerous thing, obviously. So that's a little different, because in the past, just with regular magnetos, the only way that they could be active is if we had our actual switch turned to the on position here for them. So part of the new pre-flight and post-flight checks that I will pull those circuit breakers. So they are pulled at the moment, so they have to be pressed in to make them active, and that's part of the pre-flight. Because if I crank the engine without those on, that we wouldn't get an engine start. So we have to have electrical power for engine start, and so they have to be in. But as a safety thing, I will make sure that they are pulled out at the end of every flight, so that there could be no inadvertent accidents as far as an accidental starting of the engine. So that's this test function here. Now this next switch here is also new, and that is what we call our mode switch. And as you might be able to see, it can be either in variable or fixed timing, and so it has to be in variable timing for engine start. It will not start if it's down in the fixed mode of firing. That will not allow the engine to start. So again, part of the pre-flight is to make sure that it's in variable timing. At the moment I'm being super cautious, and I am actually doing my takeoffs. Once I've started the engine, done the run-ups and so on, I go to fixed timing. I don't have to, but I'm just doing that from an abundance of caution, because that's what I'm used to, is fixed timing. So that holds the spark at 22 degrees before top center. I'm doing the takeoff and initial climb out in that fixed mode, and then once I'm at a comfortable height above, say, 500 feet or outside of the circuit area, then I can leave it on fixed if I want to, but if I want to achieve the maximum benefit, I will go to variable, and that gives you the much greater efficiency as far as the engine is concerned. So that in a nutshell is our new system, both inside and out. One other new feature that I have is this a new carbon monoxide. This is a proper aviation carbon monoxide detector, but I will do something separate on that as well, but that's working extremely well. So I hope you might have found that somewhat interesting. It's been a major upgrade. It's taken quite a few weeks. The aircraft's been out of action for several weeks while it was having the 100 hourly done, as well as these upgrades to both the battery and to the magnet or the ignition system. One additional feature to be aware of with the EarthX battery is that the particular battery that I've installed is the one that is designated for an experimental aircraft. There is a certified version, exactly the same battery, identical in every way, but it's a certified battery. I believe that new Cirrus SR22s are coming out of the factory with those EarthX batteries installed. The only difference between my experimental battery and the TSO'd one is, number one, you get a piece of paper with the certified battery, and number two, it costs about twice as much as the experimental battery. So this being a experimental registered aircraft, it was a no-brainer as to which battery I was going to choose. They're absolutely identical. It's not as though the experimental battery is inferior in any way at all. They are identical. So on a subsequent video, I hope to show you in flight some of those features and exactly what we were pointing out there. I just thought it was easy to do that on the ground here. And if you're interested in the systems, either the battery or the PMags, please leave a comment. Ask a question. I'll answer it as best I can. But we were very pleased with the help that we got from the people in the factory with the eMag system. They answered all our questions in a really prompt way, helped us through the install, and we couldn't be happier. So far, it's been a really positive experience. So I hope you enjoyed this. As I said, technical. We haven't done any flying, but the next video I expect that we'll get back in the air and show you a few of the features of what we've just discussed. Thanks for watching.